Okay, hello lads. I'm just going to go through the two textbook questions. Question 7 on page 186 first, okay? And the big clue in the question is that it lands horizontally, so we know this is theta up here, okay? Because the alternate angles. We're also told that tan alpha is a third, so we can work this out. That's root 10. 9 squared plus 1 squared is 10, okay? So this is our setup. I want you to check these, please. So pause the video, whatever you need to do. Okay, you could have down the last one here, I've subbed in the value for sine alpha. You can do that for these as well. And just as a by the by there, we have 4g root 2 times 1 over root 10 times t, okay? So you've got root 2 on top and root 10 at the bottom. So from your knowledge of surds in maths, that's the same as 2 over 10, the same as 1 over fifths. Square root of 1 is 1. So it's the same as the square root of 1 over root 5. So try and simplify as much as possible. So that's how I get from here to there, basically, right? So as I said, the big clue is that this tan of theta is minus Vy over Vx. Okay, focus camera. So we're just going to work on that. So we need to know Vy and Vx when that's the value when it hits the plane, okay? So for that we need the time of flight, and we're going to sub the time of flight into Vy, Vx. So time of flight, put Sy here equal to 0. We end up with this, okay? So you can pause this video and go through it, guys, right? I'm going to try and go through it quite quickly just to see, because I'm not sure how far you would have got. Right, so solving this, I get the time is equal to 0, or the time is equal to this, right? There's no g there, that's just 8 over root 5 cos theta. So Vx, back up here, okay? So I've converted this to over root 5 here now, right? So you can practice that just from cos alpha is 3 over root 10, okay? So I've simplified that down. Okay, so Vx, just subbing the time, this is what I get. Vy, subbing in the time, I end up with minus, which we would expect is going downwards, minus 4g over root 5. So tan theta is equal to Vy, what's the negative of Vy over Vx, so it cancels out minus. So 4g over root 5, and then this. When you do these, I'm just going to encourage you to do this again, right? So back to fractions, dividing fractions. So the first one, multiplied by the second one flipped. The root 5's cancel, 4 cancels, g cancels, so you end up with 1 over 3 minus 2 tan theta. So then we have an equation, because that one started off with tan theta is equal to this, right? So let's see if we can solve that equation now. We end up with a quadratic in tan, right? So tan, down please, tan theta is equal to this, which we've just worked out. Multiply both sides by the denominator. So 3 minus 2 tan theta times this gives me a squared term in terms of tan. I rearrange and make the squared part positive. Right, and we've got quadratic in terms of tan, right? So depending how you want to do this, some of you are happy to do this, leaving it in tan. I've done it on the side here to help me explain how I factorize, right? So let tan theta is equal to x. So it's 2x squared minus 3x plus 1. So factorizing that, you know, we can just get this 2x minus 1 and x minus 1. So x is tan theta, if you follow my pen. Right, and that's how I get from here to there. So that goes up there, right? Then we've got two values for tan, right? Or two values for tan theta, I should say. Now, it gives you if tan theta is equal to half, we want to find the key word here is magnitude, right? Because sometimes it's tempting just to put the half in here and leave it as this. But if it asks for the magnitude, we have the Vx and the Vy. That means Vx is 8g over root 5. Downwards, sorry. Vy is 4y over root 5. So we want the hypotenuse, which is y is Pythagoras, okay? So you end up with 4g is the magnitude when it lands, which is important for the last part. So the only energy at the start here is kinetic energy, because we're taking this as zero height, okay? And at the end, it's got kinetic energy and potential energy. So kinetic energy at the start is given to us, the half mu squared. The u is 4g root 2, so we end up with 16 mg squared. Kinetic energy at the end, we've found the magnitude to be 4g, so that's just half mv squared, 4g squared. But this is the problem, we don't know the height, okay? So we need to go back to the drawing. This is the height that we need. Okay. So in this triangle, right angle triangle, I have this theta from the question, tan theta is equal to half. I need to find this, so I need to know one other side. So we need to we can't really find this length, so we can find the range, can't we? So if I have the angle and the range, I can use Pythagoras. Not a Pythagoras, I can use SOHCAHTOA. Sine is opposite of hypotenuse. Yeah, so I need this. If I get that, then yeah. Okay, so we have to find the range to get the potential energy. So the time of flight was this, from what we worked out previously. Tan of theta is a half, that's given to us. So we can work out the corresponding cos and sine theta. So the time becomes 5 times 2 over root 5, which is 4 seconds. So the time of flight is 4 seconds. Sub that into the horizontal range, horizontal distance, which is the range. Okay, so go back to the equations. Simplify. We get a range of 40g over root 5. So then we go back to our triangle, right? Theta, this was h, and this is 40g over root 5. And we know sine of theta is 1 over root 5, okay? So because it's said in the question. 1 over root 5, sine of theta is equal to the opposite, 1 over root 5, h over 40g. So again, I'm doing this thing with the fractions. H over 1 is the top, the bottom is 40 over root g, so I flip that. Okay, so that becomes root 5 h times 40g. Solve that, you get h to be 8g. Put it into your total energy at the end of the time of flight. So that's the magnitude we worked out earlier. That's the height, 16 mg squared. That's the same as we got for the total energy before, which is what we expect. Total energy before is equal to total energy afterwards. Okay, question 9 then. So this is what's given to us in the question. I did say in the lesson last week it's worded wrongly in the book, right? So 60 degrees alpha. We're told that this. We're asked to show this basically, aren't we? We know the scenario at the top, the maximum perpendicular height is when Vy is equal to 0. So we're going to write our equations down again. We're given 60, so we can sub that in. So pause and check your equations there, please. We know the maximum perpendicular is when height is when Vy is equal to 0. So find Sy when Vy is equal to 0, right? So this is Vy. Okay, u sine theta minus gt is equal to 0, so we get the time that happens, and we sub that into Sy, okay? This is what we get, which is what we wanted. Yeah. So we've shown that. Secondly, it says, what's the time difference when the perpendicular height is this? Right, so we've just worked out h to be this, right? That's what was given to us in the first part. So we sub that in, h times sine squared. So u squared gives me u squared sine to the power of 4 over g. Right, so we need to know the 2 times that the perpendicular. So back to the drawing. At some point, it's here, let's say, and here. So we're going to work out the time. The 2 times, take them away and show it to be what I was asked in the question, okay? So that's the perpendicular height. So we can this part here is sy is equal to that. Right? So this is what we've got for sy at the start of the equation. This is the given perpendicular height. And we're going to try and find out some information by getting them two equal to each other. Right? So here I've multiplied throughout by 4g. Okay. And that looks like a really nasty equation, doesn't it? What we have to realize here is this is the quadratic in terms of t. Okay. So if I rearrange that, g squared times t squared minus 4u sine theta t plus 4u squared. We don't forget it's t that we want. We want the time difference from here to here. So t is what we need in terms of the other variables, I suppose. So that's what we got. Minus b formula. A is g squared. B is minus 4gu. So it becomes a very detailed minus b formula. Okay. So basically try and follow this. Difficult, I know, to try and follow this. We put in the values b minus b squared, so 16g squared u squared sine squared. Okay, done that. Minus 4ac 2a. So I've multiplied this out then. Factorize 16g squared u squared sine squared is common to both these terms, and that leaves you with 1 minus sine squared theta, and this is where this is important. Right. Now I think I said that there wasn't any relation to the table, so sorry about that. There is one here, right? But this is something that's going to be very fluent to you because it's going to come up over and over again. So 1 minus sine squared is cos squared basically, so we sub that in. That means we can get rid. All these are square numbers then. 16g, that's squared there, by the way. That's a squared there. So the square root cancels all the squares basically. So 4gu sine theta plus or minus whatever's in there squared 2g. Then what have I done here? Oh yeah, I've factorized. So 4gu is common to both of these. Sine theta is as well. Actually, I didn't realize that till I got down here. But anyway, I could have factorized sine theta here as well. What it means is they cancel the two cancels here. 4 into 2 goes twice. G cancels one of the squared ones there. We're just trying to simplify as much as possible at this stage. See if we can work something. So it's 2u sine theta plus or minus sine theta cos theta. So then we're going to do the plus and then we're going to do the minus, right? The plus one is going to be the later time, the minus is going to be the earlier time. Right, so the first one, t1, I've called the earlier time with a minus. Here I factorized the sine out as well, just so I thought it'd be easier. Looks to be easier. So that's what I'm getting for the first time. Similarly for the second time, that's what I'm getting. So if I take them both away, this is what they're asking in the question. Show the difference between the two times. The difference between the two times is this. Then we're just simplifying this out. So what I've done here is I've multiplied this in again, okay? Multiply this in again. Minus times a minus is a plus, okay, here. These actually cancel. So you end up with 4u sine theta cos theta. And when you get to here, this is what it's to show that question, right? So there is another little bit in the tables as well, I'm afraid. Sine theta cos theta, or 2 sine theta cos theta is equal to sine 2 theta. So that boils down to what we have here, okay? Alright lads.